All right, geometry 12.4a. 12.4a. We'll put that up in the corner here. And so we'll do that today, which we're going to talk about vectors. So we talked about vectors. We know what the symbol looks like. The symbol looks like that. Okay. Now a vector typically is going to be very similar to what we would call an ordered pair. Okay. And so you have an ordered pair, also would be like a vector. Okay, of a line. What were the two things that make up a vector? Would be the magnitude. The magnitude and direction. Okay, magnitude and direction. So how far it's going and the direction it's going. Okay, magnitude and direction, those are key components to be able to do this. Okay, now let's think about this for a second. If I was to think of a vector, okay, and I want to draw a vector. Let's say I have a vector, and let's say they give you a vector. It looks like this. It's on a Cartesian plane. And so it's over 3 and up 1, 4. Okay, starts there. It goes down to 1. So there's our vector, okay? Our vectors in green, our vector, right? So can someone tell me the original point, the point of origin? The point of origin is going to be 3, 4. And the point of the terminal point, which is where it ends, is going to be 5, 1. Okay? Any questions there? Is everybody good with that? So if we have a vector, that's what we're looking at. Now, here's the key. What we're looking for with a vector is we're looking for magnitude and direction. Where it's going, how it's going, and then how far it's going, okay? So what they're going to say to you is, okay, first off, let's translate that to the origin. So if I want to draw this at the origin, what would I have to do? Well, I'd have to find what the actual vector v would be. So the actual vector is actually going to be what? Well, the distance from 5 to 3, so we're going to solve 5 minus 3, and that's going to give us 2. And then we're going to go from 4, and then it's going to be 1 minus 4, negative 3. So my actual vector is going to actually be 2, and it's got little arrows, comma, negative 3, like that. Okay, so that would be how I would write a vector. Okay, it would be little arrows, the greater sign, less than sign, and then 2 because of the x value and y value. How did I get that? What I did is I subtracted x2 minus x1, so x2, x1, y2 minus y1, y2, y1. Okay, essentially what is that? That's our distance, right? The distance from there to there, okay? Now, if I were to say to you, okay, so that's your vector. And everybody agree with me, that's your vector? Okay, so that's the vector. Now, how would I translate that to the origin? So in other words, starting at the origin, it's going to go over to the right 2, 1, 2, and down 3, 1, 2. So it's going to be like this. So that is the translated vector to the origin, okay? So what you're looking at is a vector. A vector is an ordered pair, essentially, but they use the symbols, the little arrow symbols, okay? And so how do I find it? I got to subtract the terminal. I got to take the terminal minus the original. The terminal minus the original, or the initial, okay? That's how I would solve that. All right, so are there any questions? I hope you don't have any questions. It should make sense, all right? So we have the terminal is the end. This is the terminal. Okay? And this is the initial. Okay? So initial, terminal, this is what a vector looks like, and this is how I would translate it to the origin. Okay? That's example number 1. Everybody follow that. Hopefully you understand that. All right, now let's think about this for a second. If I have, all right, so essentially they're not x and y, they would be labeled a and b. So on my vector, when I solve all this, this is technically represents a, this represents b, and when you get to advanced math, you'll understand that. Now, so that's your vector, okay? So that's your vector. Now, think about that for a second. So now that I have that on the origin, so let's redraw that. Sorry, I should have erased all of it. So here's my thing, okay? And what is it again? It's 2, 3, right? So if I were to say to you, okay, so can somebody tell me the direction and the magnitude of that vector? And notice why we have to take it to the origin. You take it to the origin so that you have a standard base to go from, so to be able to find that information. So here's what you're doing. Now watch carefully. If I were to look at this, now I would draw a right triangle. Right triangle. My vertex, my vector, 2, 3. So it's going to be 2, that's a right angle, and down how many? -3, but it's down 3, right? So think about this for a second. I want the direction that's headed. The direction that's headed is this angle. Okay? So your direction is the angle of that vector. So how would I solve that? Well, let's think about it. Opposite, so sine TOA, right? So this is going to be here. It has opposite over adjacent. So what angle, what are we going to use? Tangent, good. Tangent theta equals opposite over adjacent. Opposite over adjacent, good. So if I do the math, and I do tangent is going to give me 56.3. Okay, so there's my degree. So that's the direction of that, 56 degrees. Okay, 56 degrees. All right. Now, and which way it's going in below? So it's going to go. Basically, it's a negative 56 degrees, and we will talk about that in the future. But it's 56 degrees below the x-axis. So below. Now, what would the magnitude be? What would the distance or the magnitude be? So if this is our vector, now think about this. If this is our vector, that's the magnitude if that's the direction. Well, what is that? Good, very good. Use the Pythagorean theorem, solve for your third side. So c squared equals a squared plus b squared, 2 squared plus 3 squared, c squared equals 4 plus 9, c squared equals 13, square root, c equals square root of 13. So, in this case, my magnitude of this vector is the square root of 13, and which way is it going? 56.3 degrees below the x-axis. All right, so let's try another one. Is everybody following how we did this? Okay, and you're going to do this every single time. So when you're solving these vectors, the magnitude is going to be the Pythagorean theorem. Okay, or the hypotenuse. And the direction is going to use tangent because we're looking for the angle. Okay? So let's do another one. All right, let's do another one just like this, all right? So if they give us a vector is equal to, I'm going to use arrows, -3, 3. So if I were to draw that one, negative 3, 1, 2, 3. So it's right here. Okay, there's our drawing. That's our vector. Now, first off, let's find the magnitude. The magnitude is also the absolute value, technically, essentially. So what it would be, so it's going to be c squared equals 3 squared plus 3 squared. C squared equals 9 plus 9. C squared equals 18. Square root, C equals the square root of 3 times the square root of 6. Or 3 squared times the square root of 2, sorry. All right? So we have our magnitude. Now let's find our direction. So tangent theta equals, now remember our right triangle, okay, 3, 3. So 3 over 3, right? Opposite over adjacent. So tangent equals tan negative 1, 1. And what does that give us? We have this memorized, right? 45. So which direction? It is above the x-axis, 45 degrees. So our magnitude, 3 times the square root of 2, and our direction is 45 degrees above the x-axis. Okay? All right, any questions? Okay, good. We're going to do one more example for 12.34a, and then you can work on the homework. Okay? A boat is traveling at 20 degrees west. So, do our drawing. Y, X. So a boat is traveling 20 degrees west, so if it's traveling, and at 36 knots, express the vector, okay, express the vector in velocity using horizontal and vertical components. So it's going west, 20 degrees, and at 36 knots, okay? 36 knots. So now what we're going to try to do in this case is we're looking for these two numbers. We're looking for two numbers right here. How do we find those numbers? Here's our drawing. Okay, so we're looking for X and Y, or A and B. So if this is 20 degrees, this is going to be 70 degrees. So now how do we solve? Well, we're looking for Y. So sine 70 equals Y, which is opposite over hypotenuse. And cosine 70 equals X over 36. So now all I have to do is plug those numbers in. When I plug those into the calculator, I'm really left with what? Really, I'm left with Y equals 36 sine 70, and X is equal to 36 cosine 70. And when you do the math on those, your Y is going to be negative 33.8, and your X is going to be negative 12.3. Why will they be negative? Where is this located? In this third quadrant. What's the third quadrant? Negative, negative. Okay? So when you plug those in, you can go ahead and begin to work. All right? Thank you.